Good evening. I'm Dr. Andrew LaBarbera, Chief Scientific Officer of the American Society for Reproductive Medicine. Welcome to our fourth presentation of the ASRM Grand Rounds webinar series in reproductive endocrinology and infertility. These twice-monthly webinars are designed to address topics in the AJOG Learning Guide in reproductive endocrinology and infertility. Today's presentation will be given by Dr. Rajeshwari Sundaram, Senior Investigator in the Biostatistics and Bioinformatics branch of the Division of Intramural Population Health Research at the Eunice Kennedy Shriver National Institute of Child Health and Human Development. The title of Dr. Sundaram's talk today is Analytical Strategies for Assessing Pregnancy-Related Outcomes, Fecundity and Infertility. I will now turn the microphone over to Mr. Jeff Hayes, our education specialist, who will review the details of tonight's presentation and introduce Dr. Sundaram.
Thank you, Dr. LaBarbera. Hello to everyone. I'm Jeffrey Hayes, the ASRM Education Specialist and moderator for this webinar. Before beginning the webinar, I'd like to go over a few housekeeping items. To make sure we can cover all the content in the allotted time, everyone's line except the speakers will be muted. We will devote about 15 minutes at the end of the presentation to questions. Please feel free to type a question in the chat window at any time. We will then read as many selected questions as possible to the presenter during the allotted question and answer time. If for some reason you need to step away from the presentation, please sign out and then sign back in upon your return. After the webinar is done, please do not forget to return to ASRM eLearn to take the post-test and complete the survey for your CME credit. You must complete the post-test question successfully and complete the survey to receive credit and be able to print off your certificate. Our speaker today is Dr. Rajeshwari Sundaram. We are very excited for her talk today, so I will now turn things over to Dr. Sundaram.
Thank you, Dr. LaBarbera and Mr. Hayes, for the introduction. I'm really looking forward to giving this grand rounds on analytical strategy. As Dr. LaBarbera mentioned, I'll be speaking on analytical strategies for assessing pregnancy-related outcomes, in particular fecundity and infertility. I do not have any disclosures to mention. The learning objectives of this presentation are as follows. The participants should be able to discuss basic strategies for describing their analytical plan, describe a range of analytical approaches available, and conduct and interpret analysis of fecundity data. The outline of my talk is as follows. It's basically all the components that you would have to go through to conduct your analysis. First, identify your main hypothesis of interest. Next, the first critical thing after you identify your hypothesis of interest is quantify the primary outcome of interest carefully, and then describe your study cohort and review different statistical modeling strategies. And as more and more methods have been developed, sensitivity analysis of the underlying assumptions are becoming important for a successful analytical plan. And I'll then finish with concluding thoughts. So a case study that I have used, that I'm going to be using throughout to illustrate different aspects of an analytical strategy. Successful analytical strategy is going to be to study the association between the preconception salivary stress biomarkers, mainly cortisol and alpha amylase, measured at baseline, and to study their association with fecundity and infertility. I'll be borrowing on, there are a couple of studies recently that have studied this association. One is life study, PI was Jermaine Buck-Lewis, and another stress and time to pregnancy, a component of Oxford Conception Study. I'll be borrowing heavily from the life study to illustrate various aspects. So just to give you a brief introduction on life studies, so that as we go along, you will be aware of the study design. Longitudinal investigation of infertility and the environment, which I'll be calling life study, was designed was a population-based preconception study where couples going off contraception and attempting to get pregnant were enrolled from 2005 to 2009. Recruitment was done in 16 counties in Michigan and Texas with reported exposures to persistent environmental chemicals. So one of the main outcomes of the main objectives of the life study was to assess the impact of environmental toxicants on fecundity. 501 couples were recruited and were followed for up to 12 months of pregnancy attempt. This study allowed couples to continue to participate with women suffering pregnancy losses till 12 months, so they could repeatedly get pregnant and have a loss within that time period and re-enter the study. So as I mentioned, the first objective, once you identify what your main hypothesis of interest is then to identify your primary outcome of interest. Here it's fecundity. There are various ways to measure fecundity. Excuse me, I'm just trying to control the slides. They seem to be going on their own trajectory. So the fecundity, the way it's primarily quantified, which I'm going to use since it's for illustration purpose, is it's measured through the time to get pregnant. So fecundity is our primary outcome of interest. There are various ways to measure, but from the point of illustration, I'm going to be looking at time it takes to get pregnant so that you can view this as a survival time. How long does it take to get pregnant? So the second you have time coming into play, the first question one needs to ask is, what is the unit of time that we'll be measuring our time to event in? Is it number of months to get pregnant, number of menstrual cycles to get pregnant? That's a question, that question needs to be answered carefully. Of course, the gold standard is number of menstrual cycles to get pregnant, but depending on your study, the type of data you collect, you would make that decision. And then the next question you need to address for yourself is the total length of attempt known? And I'll get back to the last point. Again, we'll go into details carefully. So that's where the issue of understanding the study design comes in. Knowing the enrollment criterion is very important for this. For example, in life study and other prospective pregnancy studies, they try to recruit couples who are planning to get pregnant. And their goal is to get couples just going off contraception and starting their attempt. But as you can envision, it's very hard to implement this in field, getting couples right at the time they go off contraception. So most of the studies recruit couples with the following criterion: couples who have gone off contraception for at most X number of months. For instance, in life study, they did 2 months. Now, what is the consequence of doing this? We are able to, first of all, from the study point of view, we are able to attract a lot more participants, but when you're quantifying the primary outcome, which is time to pregnancy, you are losing couples who are so-called super fecund, the ones who are getting pregnant right off going off contraception. Now, one needs to be, as you can imagine, this is a quantity of significant interest when you're studying fecundity. So we need to address that carefully. So what it has is, so the impact that it has is, it's a type of incompleteness of the data. Length of time of contraception at enrollment, is that known? If it is known, then the time to pregnancy is treated as a left truncated survival time, because you would know how long the couple has been. If you know how long they have been off contraception, you know how long they have been trying to get pregnant before they got onto the study. So your time to pregnancy is a left truncated survival time. If that quantity is unknown, that is how long they have been off contraception, the problem gets much harder and leads to what is called length bias in survival time. These methods get very complicated, and standard method software is not typically available to address. So typically length of time of contraception is asked in well-designed prospective pregnancy studies. If some studies don't do, they have to figure out ways to address this point. And Added to that, you will also have loss to follow-up, which happens in longitudinal studies, which leads to right censoring of the time to pregnancy. Then the next question to address our main hypothesis of interest is we are interested in assessing association between stress and fecundity. So we've looked at how to quantify fecundity time to pregnancy. Now the next order of business is how do we assess our stress markers. We have two markers that we have in the study that we had measured at baseline. That is, at the time of enrollment, those are cortisol and alpha amylase, which are salivary markers, which were measured in saliva first thing in the morning. You can look at Lynch et al. Paper for the details. I'm just going to illustrate the quantitative challenges in handling it. So the first thing you do is when you have an exposure of interest, try to identify its distribution. So what does it mean by identify its distribution? Try to look whether there are outliers. Is the distribution skewed? If the distribution is skewed, you try to use some type of transformations like take a natural log transformation so that the distribution looks a little bit more symmetric so that you can model it better. If the data is very skewed, that means there are few couples who are extremely stressed out, women who are extremely stressed out in the study. You really don't have the power to study such a skewed data. So you have to come up with different ways of analyzing such extreme exposures. The other thing that can be done is instead of looking at exposures on a continuous scale like stress, you could look at it in quartiles. You could look at your data and identify what the quartiles are so that the ones who are in the highest quartiles are the most stressed out women compared to the lowest who are the least stressed out women, and you could incorporate that in the modeling. You could go with quartiles, tertiles, or other percentiles which have a lot more interpretation. Once you have, so we have gone through two steps, identified the primary outcome and looked at various type of incompleteness. Next, we looked at how to look at stress markers, which are our main covariates of interest. Thought through if they are skewed, what to do. And then comes the most important aspect. Look at the study characteristics, that is, understand the distribution of study characteristics by the outcomes of interest. So we are interested in fecundity, that is, whether a couple can get pregnant or not. Since it's a longitudinal study, we may have loss to follow up or couples may withdraw. So the first thing you need to do is look at essential characteristics of the study participants. I'm just giving you an illustration over here like female age, male age, and I'm going to just take those two to to point out. You look at all the host of socio-demographic factors, lifestyle factors, and so on, and compare them across pregnant, not pregnant, and withdrew. It's very important to track how the couples who withdraw, how do they behave compared to these characteristics? Are they significant? Are the older couples the ones who are dropping out, or are the younger or the ones who have extreme lifestyle factors? Those are the type of things you need to answer. So you look at the description of various characteristics and compare it across. Here we have compared it across pregnant, not pregnant, and withdrew. And then what you do is you compare the means if it's a continuous measure, or compare the percentages if you look at number of months of trying prior to study entry. And then you do either a t-test to compare, do a ANOVA comparison or a chi-square test comparison to see is one of the group significantly different from the other. So for the age, we reported mean and standard deviation in the first line. And for the number of months, it's basically the count and the percentage in the study. And we did not find any significant difference between the three groups. So that's an important fact to understand. So this points out that people who have withdrawn are not much older than the people who remained in the study. And again, the another factor that we did mainly for convenience, but an important factor is number of months of trying prior to study entry. This is the number of months of contraception. We have our study enrollment criterion was they could be at most 2 months off. So there would be couples with 0 month off, 1 month off, or 2 months off. And when we made the comparison across the groups that withdrew versus the ones who got pregnant or not, we did not find any significant difference. The last two, these two lines, cortisol and alpha amylase, also convey an important fact. These are our main covariates of interest. So the first question that we want to make a comparison is, are the people who withdrew, are they more stressed out? So when you look at the mean, so what's being reported over here is the mean and standard deviation in the parentheses. So you can clearly see that for cortisol, they are all comparable. When you look at the mean values, 0.4 for pregnant, 0.3 for not pregnant, and 0.4 for withdrew. Alpha amylase, again, it looks like not pregnant are slightly higher. But when we do the testing, what's more important is the withdrawn group different from the other two groups? And we didn't find any significant difference between the two groups. So there are more details on what was done in the paper, but from the point of view of moving forward, these were some of the critical things. And the other quantity that we had also looked at is the average daily stress per menstrual cycle. And again, we didn't find that to be significantly different. An important issue to look at in this study is that's where the enrollment criterions are. You need to carefully understand who are the people you are including. Is one question that can come up is, are the couples who are more stressed out, are they the ones who are joining the study? So you need to and that could bias your findings. So the first thing we need to do is, again, compare the stress markers across the couples who had 0 months of contraception when they enrolled, 1 month off, and 2 months off. And again, we did the p-values talk about the comparison of the mean levels across the three groups. And you can see that they were not significantly different. I think all this points to the study. It defines your population that you're looking at, and it's pointing out that we are not just capturing couples who are more stressed out or less stressed out. They are all comparable across the various characteristics we have looked. Now that we have looked at the descriptive part of our analytic plan, the next most critical part for studying an association is building your model. Time to pregnancy is a discrete survival because you can only get pregnant once in a menstrual cycle. So it's not a continuous time. You cannot get continuous at any point of time in any menstrual cycle. A couple cannot get pregnant. So it's a discrete event. So keep this in mind, that the way to handle discrete survival is different from the way to handle continuous survival time. For example, those are time to a heart attack, time to death. Those are more on a continuous time scale. So when you use different models, you have to do it carefully. And there are models that are available, and they can be easily implemented in SAS and Stata, some of the common softwares that are used. I'm just going to present two models which are the most popular ones. Cox's model for discrete survival. When you deal with discrete survival, keep in mind you have, instead of hazard ratios, you will have odds ratio. Because we are assessing fecundity, it's typically called a fecundability odds ratio. And then the next model is proportional hazards model, which gives fecundability ratio, also known as proportional probability of pregnancy. And as I mentioned already, that SAS, data, etc. and R software, for those of you who are familiar with it, can implement these methods. Typically, it's same proc pH reg in SAS, and you just have to choose the option tie is equal to discrete so that it knows it's a discrete survival and not a continuous survival. And so once we identify what model to use and we know what is our main covariate of interest, next question to address is what are the other confounders to adjust for in your model. Some of the common approaches are based on your choice of confounders is made a priori. Excuse me again, I'm having, the choice of covariates is made a priori. That can be based on previous literature. For instance, in fecundity, one would use age. Definitely one would adjust for female age and male age, perhaps difference between male and female age, and so on. And the other alternate approach is which is nowadays is what are directed acyclic graphs to identify important confounders. And since we are dealing with a time to pregnancy and it's a longitudinal event, you have to also keep in mind that with stress, one would also want to include lifestyle. But once you have lifestyle factors, they can vary on a daily level. For example, smoking, alcohol, and caffeine, or it could be measured at a menstrual cycle level, depending on the amount of detailed information you have in your study, or just simply a question that was asked at baseline. So simply put, when you're dealing with survival times, you need to worry about, are your covariates time varying or not? In some situations, it may be just enough to average them across the pregnancy attempt time period, because that's the time we are looking at, the length of time they take to get pregnant. If you just average those lifestyle factors, then they are going to result in what are called fixed covariates, which are easy to model. But what's known in the fecundity literature is lifestyle behavior tends to change over time, pregnancy attempt window. So I'm going to quickly show this example to point out, this is a paper that we brought out in American Journal of Obstetrics and Gynecology. And what we had looked in that paper is, do women change their behavior over time? And answer is, initially for the first few months, if you look at the panel in A, it shows that if you look at the first one, is the ones in triangles are the smoking, alcohol is circle, and caffeinated beverages are square. You can see that as this is mean change in lifestyle factors, daily consumption, and you can see, and the x-axis is the cycle number. As time progresses, you see couples starting to, that means they're taking longer to get pregnant, they're starting to change their behavior. And the B panel talks about, did they intend to change the behavior? The solid lines are the ones who said, no, they don't intend to change their behavior, but you can see a downward trajectory even with them. So over time, the longer it takes, people do tend to change behavior. So that basically says that when you look at lifestyle factors, you do need to incorporate them as a time varying covariate. Now for our main, for the case study that we are working with, where we are trying to assess the association between stress and time to pregnancy, this is the conceptual DAG that we used. Age, you can see that the female age and male age definitely are important factors for time to pregnancy. Age impacts, we had only stress marker on the female age. So female age does impact stress. We are interested in the association A between stress and time to pregnancy, and stress can impact lifestyle factors. So, and those can impact time to pregnancy. I'm not going to go into too much detail, but the point to worry also is longer it takes to get pregnant, they may be more stressed out. So based on this DAG, we decided that we would be using the following factors: age. We would adjust for age of female. So keep in mind, when you are putting in female age, you cannot just insert male age into the model because those are highly correlated. On an average, there's a difference of 2 years between male and female age, and income, race, females' lifestyle factors, smoking, caffeine, and alcohol, which were put in as a time varying. And the other points to keep in mind is, because we had let couples enter with at most 2 months of contraception, so we have to account for left truncation. During the study, they could drop out, so it leads to right censoring. So our time to pregnancy is a discrete survival, which has left truncation and right censoring. And we model the biomarkers as continuous as well as in tertiles, because we found alpha amylase to be a bit skewed. And when you see that, so these are the results of running the association using a Cox model. Notice that it's a discrete survival, so I don't call it hazard ratio, it's an odds ratio. We are assessing fecundity, so it's fecundability. So when you look at alpha amylase, this is when it's put in the model as continuous. This is the unadjusted model with the odds ratio and 95% confidence interval. The same here, adjusted odds ratio with 95% confidence interval. So we see a decreased odds for getting pregnant the higher the alpha amylase value is. Then when we look at it in tertiles, where the lowest is the referent group, that means these are the least stressed out women based on alpha amylase measures, you can see a significant decrease in the highest tertile compared to the referent group. And when we looked at cortisol as a marker, we did not find any. We saw a reduction in odds ratio. That means they had lesser odds for getting pregnant in a given cycle. That means it would take them longer, but no significant finding. This finding basically corroborated our previous paper on the same, but we had used a different study to analyze. And once we have found that the highest tertile of alpha amylase increases to a longer, leads to a longer time to pregnancy, another way of presenting this information is graphically. So these are survival curves. So probability of not getting pregnant, and that's the y-axis, and x-axis is the unit of time, which is cycles, menstrual cycles. You can clearly see that the highest tertile is the one that's going to take longer time to get pregnant. Now, so just to wrap up our previous, what we have discussed so far with fecundity models, there are existing softwares which can be used to assess time to pregnancy, but there is also a unique feature. It depends on the amount of data you have. If you have also intercourse related information, then it's better to account for, because if a couple doesn't have intercourse around the time of ovulation, they cannot get pregnant. So to make sure that immaculate conceptions do not occur, there are models which have been adapted to to do the same modelings which calculate fecundability odds ratio or fecundability ratio. But those are not freely available. We do have the software available on our website. These are some of the references. Now moving on to the next point, another issue that is encountered quite often is repeated outcomes. I'm going to borrow from Sapra et al., which just appeared in Human Reproduction, where the motivating question was, is time to pregnancy similar across successive pregnancy attempts among women experiencing pregnancy loss? So remember when I said that this study allows for couples to continue even after they experience a loss till censoring? So we do, so live study does have that information. So you may have, so what you would have is women who are experiencing a loss would have repeat time to pregnancy. And the summary finding was TTP after a loss may be longer compared to TTP before a loss. And now the main point I want to mention about this analysis is you have to be careful when you analyze such data. We'll still use the Cox's discrete survival model, but you have to keep in mind that one woman will now contribute more than one pregnancy because she has suffered a loss, so she would have repeat TTPs on her. So you have to remember to use clustered time to event analysis, where woman is the cluster. And what would happen if you ignored woman as a cluster? That means now your data size would, if each woman, let's say you had 100 women and each had 2 TTPs, you are now increasing your sample size from 100 to 200 if you ignore the clustering concept. So it's critical to keep in mind which is the independent unit of analysis. Here it's woman, not TTP. And then when you have clustering, the next important thing is when you calculate the standard errors, you have to use the robust standard errors, which would account for this dependence within the woman. And I'm going to now move on to the next idea. As I mentioned, that as we go along, in most of the analysis nowadays, we do look at sensitivity analysis, which is an important concept. It's basically a way to test your assumption. And I'm going to again use Mumford et al., Journal of Nutrition 2014 to illustrate our point. This paper studied the association between male and female urinary phytoestrogens, isoflavone and lignin concentrations, and time to pregnancy. And the summary finding was female urinary lignin concentrations at levels characteristic of the US population are associated with a shorter time to pregnancy among couples attempting to conceive. So when you look at, I'm just going to straight get into the results and point out that it looked at both the female measurements of phytoestrogens and male measurements, and what we found was the lignans led to an increased fecundability odds ratio. I'm just going to point out the unadjusted. For our point, you see for enterodiol, you see an increased odds which is significant. Same for enterolactone, you see an increased odds for getting pregnant. The same when you adjust for. I'm not going to get into discussion on what are the factors we adjusted for, but point out they were the usual age, BMI, race, triglycerides, creatinine because it's a urinary measurement, supplement use, and physical activity. Now we also, since we had both male and female phytoestrogens, we had adjusted for, when we looked at her measurement, we adjusted for his measurement of that. And you can see enterolactone stays significant throughout. So when you look at the odds ratio, the confidence intervals exclude 1 and they're greater than 1. So that means there's a higher odds for getting pregnant if the lignin measurements are high. Now this finding seemed to be consistent and robust to our adjustment, but what we realized as a limitation of our study is for phytoestrogens we did not have a measurement of dietary intake. So we could not adjust for her fiber intake. So what we did is, since an important confounder was missing, we did sensitivity analysis where we generated dietary variable with various correlations with the measured phytoestrogen levels. So what we did is we repeatedly generated data with various amount of correlation between phytoestrogens and the dietary variable which we were generating. And we found that the association remained significant. So our findings were robust even though we had limited data on no data on dietary intake. And I'm only going to show the first panel. So if you notice the ones what this is, the rows are basically the correlation between the diet variable and phytoestrogen. This is saying that there is no correlation between dietary variable, which is unmeasured, and phytoestrogen value, which is not necessarily the real situation. And we expand the correlation up to 0.9. That means we say most of the phytoestrogen measurements that we have can be attributed to dietary intake, which is also an extreme. So we generated data in different scenarios, and we again did the analysis and assessed, is the enterolactone's significance, does it still stand? And as you can see, the ones with the squares are the unadjusted analysis, the one with the diamonds are the adjusted analysis. So as you go along, you see that it doesn't, the significance still remains. So the findings are consistent. So our conclusion was that our results remain steady across different choices of correlation and different effects of dietary intake. So these A, B, C, D are different measures of impact of dietary intake on time to pregnancy. So we found our results to be robust. So this is an important, so in absence of some important confounders, or if you feel that you have some assumptions in your modeling that are not perhaps, that may be too stringent, what you need to see is relaxing those assumptions. How far does your finding go from what you're reporting? And that kind of concludes the your analysis. Now I'm going to shift gear a little and move on to another outcome. So right now we have looked at time to event as an analysis with time to pregnancy as an example, and we looked at how to handle repeated outcomes on time to pregnancy, and we discussed a little on the importance of doing sensitivity analysis. Now finally I'm going to move on and look at infertility as a primary outcome. But the second we get to infertility, the definition that we have used is, it's defined as inability to conceive spontaneously in 12 months. So you would definitively know an answer, yes, she got pregnant in 12 months, no, she did not get. So the primary outcome now becomes a binary outcome. So the modeling options now go down to, for binary outcomes, you can use logistic regression. But keep in mind that logistic regression gives odds ratios, or you could use binomial or Poisson regression, which gives relative risk. Now, which of the two do you use depends on how rare your outcome is. Odds ratio and relative risks are comparable only if you're dealing with a rare event. Infertility is not common, but it is also not very rare. So if you use odds ratios in a common type of event, the associations can be magnified. There's a lot of literature that talks about relative risk being a better measure of association than odds ratio, and it's more interpretable. And for both, whether you choose the odds ratio approach or relative risk, softwares are easily available to calculate either. So again, I'm going to go back to live study and again use our Lynch et al. Paper to illustrate this point. So as a follow-up of, so in the first part of the paper, we had looked at our women's salivary stress levels measured at baseline, prospectively associated with time to pregnancy. So the next one was, and we did find alpha amylase in the highest tertile significantly reduced the odds for getting pregnant. Now we are looking at, okay, it takes her longer to get pregnant, but does it impact her chances for getting pregnant at all? That means, are the associations significantly associated with infertility? And our summary finding was, yes, higher levels of stress as measured by salivary alpha amylase are associated with an increased risk of infertility. And I'm going to again point out, remember we had looked at alpha amylase in two ways. In one, viewed it as continuous in the model, and we and then we looked at it in tertiles. So when we put in the model as continuous, the left two columns are for unadjusted relative risks and confidence interval, and then this is the adjusted with its confidence interval. Again, the covariates that we adjusted were dictated by the DAG that I had shown you. And what we find is whether it's unadjusted or adjusted, we found an increased relative risks for infertility. So it's 1.4 times higher, relative risk was 1.4 for being infertile. And when you look at the adjusted, it was 1.5. Now, when you look at the highest level of highest tertile of alpha amylase, you find it's 2 times. So a woman with the highest level of, in the highest tertile of alpha amylase has a 2 times the risk for infertility compared to a woman in the lowest risk, keeping everything else same. We did not find any associations with cortisol and infertility as we had found with TTP. So in conclusion, what I've presented so far is we have looked through two different outcomes, time to event. An example of that was time to pregnancy, and infertility, which is a binary outcome. And it's choice of the understanding what the study objectives is important to design an appropriate analytic plan, and understanding your enrollment criterion and who are the people who are included and excluded is very important so that you can account for various unmeasured time due to study designs. In prospective study designs, pregnancy study designs, you typically give a certain leeway to recruit couples who have gone off contraception for a certain length of time. And if you were doing retrospective, you're only going to follow, which I have not discussed, but it has its own challenges. And if you follow couples longitudinally, there is always a risk for loss to follow-up, which needs to be accounted for by right censoring. Unmeasured time of contraception is modeled by left truncation. And then you need to understand the missing data carefully. So we looked at the stress and saw how it changes. Does it change significantly by number of months of contraception? And we did not find any significant difference, but if you do find significant, that leads to informative missingness. So that means you have you have lost couples who are more stressed out, so you need to use proper analytical strategies to handle such informative missingness. And then when you're dealing with repeated outcomes, you do need to identify your independent unit of sampling. So if you have repeat TTPs, you cannot ignore the fact that they are coming from the same woman because she is the independent unit. If you ignore and treat all the pregnancies as independent, you're inflating your ends and you get an inflated power, which is wrong. So in presence of repeat outcomes, you do need to use robust standard errors when you deal with them. And do sensitivity analysis when important factors are missing, or if you make assumptions that need to be tested. If you feel they're strong, you need to relax them and see what happens to your findings. And this is where I conclude my talk, and if you have any questions, I'll be happy to answer.
Thank you so much, Doctor. That was an amazing talk. We have been taking questions. If you have a question, we have a few, but if you have some questions that you're thinking of right now, go ahead and type them into the chat box, and we'll be happy to review those and ask. I'm going to turn things over now to Dr. LaBarbera.
Thank you, Dr. Sundaram. That was very interesting, and we'll try to paraphrase the questions that have come in thus far. And one has to do with stress and the definition of stress in your studies. I think it's well established that stress, documented stress or induced stress in animals and humans does in fact lead to increased cortisol levels. It would appear that you accept the inverse, that a elevated cortisol level is an indicator of stress, or cortisol and alpha amylase. Have you done any validation to correlate the increased levels of cortisol and alpha amylase actually with some physiological or psychological assessment to confirm that in fact when these are elevated the person is in some kind of stressful situation? And what kinds of stressful situations would you see in your studies?
So these are all excellent points, and the points I know during our review process we did face. So just to point out, these measures were done in if you look at Lynch et al., that explains in detail the laboratory measurements, where the stress were measured. And there are papers that have come out and they have shown that with elevated stress, the salivary markers do show an increase in alpha amylase and cortisol. What we had going into this analysis, we had thought that we would see more of an association with cortisol, but we found it more with alpha amylase. That said, this is the second study where we are finding. The other study that I mentioned in my second slide, but never use it for the rest of the talk, is the stress and time to pregnancy in Oxford conception study. We had similar findings where we had measured the salivary markers the first thing in the morning I want to say the first day of the menstrual cycle or the 5th day, I forget. On her first non-bleeding day is what I want to say. The salivary marker is measured, and we found the same association with alpha amylase, leading to an increased time to pregnancy. So we had also looked at fecundity measured through other outcomes like daily probabilities of pregnancy in the other study. But here we also found with the length of time, and which is more interpretable. So we have we discussed that more. But yes, there are findings that show, there are papers that I don't have the reference offhand, but they're listed in Lynch et al. And in our previous paper, where we do mention the associations between higher stress level with these markers.
Thank you. Excellent. Another question that has come in has to do with lifestyle factors. And the question is basically, if you if you have not powered for smoking or caffeine use or alcohol consumption as primary markers in the study, can you, if you think of them later, can you go back and analyze those? And if you can, then how do those compare over many decades? Do you see that there have been changes in fecundity with the changes in smoking, for example, in the United States, or with alcohol consumption? And the reason that I could see that would be would one want to propose that the people in the 1950s, for example, that women or couples in the 1950s, maybe where smoking was much more prevalent, were they less fertile or less fecund than couples today?
That's a very interesting question, because I find this extremely interesting, because we are also looking at it. It's a totally difficult, very important, but a very hard question to address, that are the fecundity trends changing over time, and what is attributing. We, most of the developed countries like, Denmark and others, where they're seeing a decrease in fecundity now, but we also see a decrease in smoking trends. I mean, definitely for United States, we can say for sure the smoking trends have gone down. Now, the association, smoking is definitely, our study was not powered. The examples that I was using was not powered to assess the association between smoking and time to pregnancy, because the prevalence of smoking was very low in our study. But what we did find is, because we did look at smoking, and women tend to change their behavior along the way. So that's, the longer it takes them to get pregnant, they are also changing their behavior. So they are reducing the amount of caffeine consumption and smoking and so on. And so, to get to this question, it's very hard. And right now, so the examples that we looked at was, we knew we were powered to study the association between stress. So the only reason we wanted to adjust for other lifestyle factors is higher stress also. As you saw in the DAG, we wanted to also account for lifestyle factors, which were an independent factor for time to pregnancy. And even with this, we do see reduced odds for getting pregnant with the smoking. But women in these studies, you may have the numbers in front of you with the paper, don't smoke so much. But any smoking, I think, has a detrimental effect for sure.
Thank you. And there's one other question here, which has to do with the definition of the patient or the study population in fertility and infertility. So I understand that these are studies that you've been conducting. Do you correct, for example, or do you verify, or how do you correct for people's frequency of intercourse?
Intercourse, yes. This is, so what we had, for sake of time, that is some aspect that I didn't get into, but what we did look at is, it's a very important factor, because frequency of intercourse at the right time definitely plays an important role. It is going to be significantly associated with time to pregnancy. What we did look for is the frequency of intercourse different across various stress levels. Did we see, and we didn't find a significant difference. So you have to keep in mind, this is a preconception. This is a cohort of couples who are trying to get pregnant, who want to get pregnant. So, and they are provided with fertility monitors, which tell them around what time would be the peak ovulation for them to try to get pregnant. So these couples around that time of ovulation would be well informed to have intercourse. So we made various comparisons across the stress levels, and we didn't find any significant difference. And in the final analysis in our model, we also account for the frequency of intercourse in the fertile window, and we did not see any change in our findings. So it still remains significantly associated with the decreased odds for pregnancy. But that's a very important point to address. And we have,
Thank you. I will turn it back over to Jeff Hayes now.
Thank you so much, Doctor, and thank you for everyone attending tonight's webinar. This is the fourth in a grand round series of webinars the ASRM is presenting. Our next webinar is Tuesday, November the 17th at 10 a.m. Eastern Time with Dr. Stephen R. Goldstein, who will present on early pregnancy, normal and abnormal, how to use ultrasound and HCG successfully. Look for an email from ASRM with registration details soon. Also, this and all of the ASRM Grand Rounds webinars are posted for rewatching after the initial broadcast. Look for an email from us about that, or if you missed the email, don't worry. You can visit the ASRM website and look at our Grand Rounds webpage for further information. Thank you again to our speaker tonight. Thank you to everyone for being here. This webinar is now ended.